Okay, now there's our old introduction to the website when Joe came to Australia. We're upgrading all of these things over the next couple of years as well. So pray, and as Sam said, it's really donation research. No, he didn't mean that, but I thought that was a good line. I think we'll spread that one in America. That's what we were doing when Joe came to Australia. You can go and see quite a bit of the stuff I'm about to talk about on our experiment section. So go to creationresearch.net, click on research, click on experiments. All right, so when we have a look, where is my screen gone? Joe, why isn't that advancing?
You might
There
want to
we are.
just click. That's it. Yeah, you're right.
I think so, yes. No, something's gone wrong here
Just
somewhere.
just just click on the presentation, and then go left and right.
There we are. It's come up. It was hidden by the actual message. There we are. Here's what we've been doing for the past 3 years, working on my thesis that I gave to the Sydney Basin Coal Conference, that clay is a key for making coal and carbonising things. There's our starting point. Green ferns. Why ferns? Because they're commonly found in coal. Real world stuff. Okay, there's our most significant early one. You'll see we date the bag 24th of 1st, 2020. So it's really only three years ago, really. You can see there's a green fern inside it, one of our common ferns. And a few weeks later, that's what it was like. No, it didn't take millions of years. It didn't even take millions of months. It didn't take millions of days. It just took a few weeks, and the fern was carbonized, just like you see in the fossil record. And there's a reminder about what it was like when we started. Now, as we thought about this, A, I already knew that this was the background to what was happening, but B, we hadn't actually proved it. C, we were making fossils in a very short period of time. And yes, we've done the testing. This is carbon, it's coal even, and we've checked with the professors. Yes, it's easy to prove that, but it didn't take time. But the question was, why would it happen? What's the clay doing? Now, we've continued this for the past few years, and our new series of books on not time but process will have a lot of these pictures in. Go to the website, click on experiments, click on research. This one here was started just last year on the 9th of the 1st, 22, and it was open on the 12th of the 1st. So we're looking at 1 year. One fern buried along with its tubers, and look, 1 year, and you have beautiful carbonized. When we scrape the clay off the top, these are the sort of carbon you see in fossils. Carbon, by the way, is naturally black. It went in there bright green. But what's causing it? Is it just the clay? Well, we've got a display at Jurassic Ark on how to make coal quickly. It's a very popular display because it shatters people's total brain set that they need millions of years. It also upsets people who say you can't use all the coal because it's a non-renewable resource. Now, as far as we're concerned, if you can make it in a couple of weeks, it's an absolutely renewable source. Fascinating conflict. God gave us dominion over the planet, and even making coal is part of that dominion. Speak to the earth, and it'll teach you what God has done in the beginning. Well, here we are up to just last week. There's Daryl cutting. Daryl's our curator, by the way. That's a beautiful view of Daryl and a couple of Queensland dinosaurs beside him in our living fossil garden at Jurassic Ark. He's hacking off a branch of one of this southern Araucaria pine tree. Oh, he did this nearly 2 years ago, and we set up this experiment to actually get running. All right, you notice again the hoop pine branches at the top, because the clay in Australia, coal in Australia is full of pine bark, but very few branches. The coal in Australia is full of ferns, but very few tree trunks have turned to coal at all, if any, only on the outside. So we took some small scale ones, we embedded them in clay, wet clay, and you'll actually find we didn't use council water, by the way. We just used rainwater or dam water, and then we vacuum packed the bags. And just 2 days ago, we opened up the bags. Now, there we are, close up. You can see I've used the knife, just showing at the bottom there, to push the bark off the outside. The tree in the middle is still just pine tree. No, we don't wash this because we want to leave all the evidence as is. Pine tree in the middle and what looks like two bits of black stuff around the outside. The pine wood, by the way, is still white, just like it was when you cut it off. Oh, but now you open up a bit further. Do you notice on the right-hand side, there's a layer of the bark that seems to be still uncoalified, or it's not gone black. It's still the same color as it was on the tree. And there's the pine tree in the middle, which is still the same color as it was in the tree. But the layer of bark between the outer bark and the inner tree has gone jet black. Well, let's just give you a reminder. Here's Daryl again cutting the same branch, and there's the branch at the top. You notice we've trimmed off so you can see the inside color, it's light. You can see the outside bark, which is brown, but in between the two is a chlorophyll rich zone. Okay, now go down the bottom. You'll see on the outside, there's the layer of the brownie bark, which is still brown. And then there's the pine tree in the middle, a bit dirty, of course, but it's not gone jet black. And then there's the chlorophyll layer, which actually has. Now, why did we do this? Well, I've been suspecting for quite a while there's several factors involved here in making clay, and you can read all about this in our book, the coming up on Not Time But Process, that there's two or three factors. One is the time of the year when the plants were growing. It had to be an active chlorophyll production time, like in Australia, early spring or late summer when you get your rains out here and things begin to grow again. And it had to be the chlorophyll rich. If the chlorophyll was gone or it was stagnant, then none of this carbonization would occur. And there was also the role of the clay. Now, the clay on the outside little bit of bark doesn't seem to do anything because that part of the bark doesn't have any chlorophyll. The inside of the tree is wood. Now, let's be honest. Most people think coal seams form from millions of years of trees growing in swamps and then they carbonize. Sorry, the Araucaria trees, the bark of which makes up most of our coal seams, does not grow in swamps. And the outside of the tree, well, I'm sorry, that little bit stays that dirty brown stuff. And whether you're using dirty brown leaves or dirty brown dead bark, because that's the point of the bark on a tree, it's dead to protect the tree. The only part that goes to the coaly stuff is the chlorophyll rich bark. There we are. Bottom one there, opened up. Top one there with the tree with chlorophyll, and the one on the right showing you the distinctly different phases there. All right. Here's a different view of the same thing. My hand for scale. Okay, do you see the bark at the top? We've lifted it up deliberately. You see the two bits of the live bark and the tree in the middle? Go a bit closer. The dead stuff at the top, do you see the nicely outlined white bit? It's still exactly the same color after 2 years in the clay that it was when we started. It has not carbonized. There was no chlorophyll in it. Then you have a look at the next layer down. Do you notice how it's gone to jet black? Right? It's gone to jet black coaly material. And by the time you get to the bottom, it's done exactly the same. And then when you have a look on the right-hand side, it's not the brown stuff that's gone carbonized. It's not the stuff in the middle, which just looks like charcoal covered on the outside. You scrape it, and we did that, and it's white, but I ran out of time to put it up there in the morning. So we've reached a conclusion that our initial thesis that it's the active growing part of the wood, it's the active growing substance chlorophyll, which is necessary to producing carbonization or coal. Significance? When did Noah's flood start? Don't go by where the layers are in the rocks because that will lead you totally astray. It started in a time when chlorophyll production was active, when chlorophyll production was maximum, and when the plants would have been beautiful and the climate was the best you could possibly get. And the plant itself had not been too old. These are new growth plants. You see, it matches what we find out there in the real field. There's Darryl for scale. There's one of our pine trees dug out of our Jurassic rocks. And what you find is mostly the trees you dig up are minus their bark. And many of them see the damage to the tree at the top. top. Many of the trees we dig up are damaged on one side. All the indication of volcanic eruption force that's come from one area and blasted them down. And then you find there's no bark, and the trees do not go to coal. If they get preserved in the coal seam, they will petrify. No chlorophyll in the tree, it doesn't get preserved as coal, it will go to silica perhaps. Have a look at one experiment on getting other chemicals into the trees and the results. 27th of the 9th, 21. That's not too long ago, a year and a bit. Now, buried kauri leaves, excavate them just this week, put in live ones on the left-hand side. Look at those beautiful fossils. Man alive, it didn't take time, it took the right process. I mean, there's almost every part of that tree in the leaf has been preserved in a magnificent, you love getting those fossils that are black and shiny. Well, we've done it in less than 2 years. We didn't need millions of years. We didn't need vast amounts of pressure. We didn't have to bury it. We've just put it in a airtight container and buried it in the right sort of stuff, and you end up with beautiful fossils.